Hi everyone, welcome back to another video. So I just got this new oscilloscope. It's a Hantek DSO5102P USB digital oscilloscope. I'm absolutely in love with it. I'm gonna unbox it now and I am excited. So what we'll do in this video is we'll unbox it first of all and we'll talk about some of the specs that the oscilloscope has. Then after that we'll turn it on, run some tests, do some tests and measurements. Comes with this plug. I don't know why it comes with this plug. Not great, but I'm going to be using a typical plug, so won't be using this plug. Don't advise you guys to use it. But yeah, so we'll turn on the oscilloscope. We'll maybe like run some measurement tests. These are our nice probes. I look forward to talking about these probes. I'll mention them in a minute. Then I'll show you some of the cool features that this oscilloscope has, which I'm really looking forward to, such as like USB saving your data, which I'm super excited about. Comes very well packaged. Look at that. Then I'll show you the software that actually comes with this oscilloscope that you use on the computer. We'll go through the manual, take a look at some of the reviews, which definitely caused me to buy it, because when I read the reviews, man, everyone just had positive things to say about it. Literally, the only negative thing that anyone said about it was just about this plug. That's it. But you know, I'm sure you could find that plug yourself. You know, you're gonna have loads of them at home. So, and yeah, then we'll just round off the video with like some extra testing. But other than that, this should be a good, quick video. I'll try and keep it brief. And let's take a look at this really nice scope. Look at this, man. Oh, that is beautiful. Look at that. It's really nice. I love it. I really like this blue. And a really nice blue. Look at this. Look at that. Carrier handle. I like it. It's nice. Alright, so that's the scope. Let's see what else is inside the box. So it comes with a little UK adapter, which I'll just say right off the back, don't bother using this because it's not grounded, so you don't want to use this. USB, which I'm really excited to talk to you guys about. And finally, manual, CD, etc. So yeah. So this is everything that the scope came with. We're obviously just going to ignore these, right? So don't bother using these. So I must say, I'm really surprised to see this whole thing cost me £170, which I got from Banggood. And even more amazing is that even though I got it from obviously a Chinese website, Banggood, it was shipped from the UK. So I actually got it delivered in 3 days, which is amazing. So £170 for UK shipping for this absolute beautiful machine. Now, I'm actually a second-year electrical engineering student, and I've never used a full-size oscilloscope, thanks to obviously the whole online student stuff. So I think in a few years' time, we're going to have a lot of very underskilled electrical engineers who learned their whole course online and only learned how to use an oscilloscope off of multisim. So thankfully, I've got my first oscilloscope here, and I'm well excited to use it. So you can also actually get this on Amazon for £230, but again, considering Banggood are shipping it from the UK for £50 less, or £60 less, it's a no-brainer to go for this from Banggood. So the oscilloscope comes with these two probes, so basically two sets of probes, right? One for each channel, because it's a 2-channel oscilloscope. These probes are called the PP150s or PP150s. I'll talk about them a bit later on in this video. Also comes with this USB cable, which actually is used to plug into the back here and use that to connect that to your computer, which is, I'm really, really excited for this one. Comes with a CD, which I believe has the manual on it, and also might have the software, I'm not sure, but I don't know who uses a CD these days, so I'm going to download it all online, which later on in this video I'll show you how to download the software and also how to get the manual as well. And then it comes with like some sort of certificate to say that it's their product. But yeah, I'll just disregard all of this, not going to use any of this for now. Okay, so that's what's in the box. Let's talk about some of the things that I like. Firstly, the look of it is absolutely beautiful. It just looks amazing. Like, man, like that on my desk. Look, Ma, I'm a real electrical engineer. Looks amazing. Look at that. What's even like crazy is that look at the color of my wall and the color of the oscilloscope. It literally matches my wall perfectly. It's a really, really, really nice blue teal color. I love it. It's absolutely amazing. I love this little carrier handle case that it's got as well. And the whole scope is only 2 kilos. Really good handle as well, as you can see. I'm holding it sideways, no problem. Only 2 kilos, doesn't weigh a thing really. Here you can join me in taking off this little screen cover. I messed it up there. Boom. And as you can see there, like immediately you can see the reflection that you was getting was from this, which I know some of you might have been concerned about. But yeah, once you take that off, you can see it's got that whole anti-glare coating on it or whatever. So the screen, it's a really nice screen, and you can see there that you can't see my reflection at all. So when you're actually using it, you're going to get a much better, really nice viewing angles on this, which is good. I'm super pumped about this USB stick, where basically you can hit capture on the scope and then put a USB drive in there, and you're able to save information, which I'll show you how to do that later on in the video. And as I mentioned, this USB port at the back, again, really like it. And really, actually, what I really appreciate is the fact that this bit here is sunken into the oscilloscope, so I can actually rest it up against my wall with the power cable in there, and it's not going to stick out. Like, imagine if it was there, for example, you'd have the scope kind of like bent out like that or whatever. So this being sunken is really nice. Okay, so let's talk about the specs and then we'll turn it on and get started. So the specs that stood out to me mostly is that obviously it's 100 megahertz with a 1 giga sample per second rate, 2 channels, which I'm never going to need more than 2 channels. Well, not for now anyways. It can take up to 40 kilopoints of memory, which apparently, according to some people online, is not that much, and some people are complaining that it doesn't take that much memory. But as far as I'm concerned, you know, I have the USB stick. I also have the port at the back to connect to my computer, so 40 points of memory should be more than enough for me. The screen is what I really like. 7-inch screen, 800 by 480 HD display, and anti-glare, which is nice. The time range on this is 20 nanoseconds to 10 seconds, which is obviously more than good enough. I'm not going to be operating with things where I need to see less than 20 nanoseconds. Probe lengths, which are actually really nice. They're 1.2 meters long, or just under 4 feet long, which is, again, perfect. So that way I can have my scope all the way at the back of my desk and easily work with it from there. In terms of size of the scope, it's 38 centimeters this way, it's 20 centimeters this way, and 24.5 centimeters height. So 24.5 centimeters height, 20 centimeters depth, and 38.5 centimeters long way. So I'd say it's fairly small, but also, yeah, I think it's more than good enough, especially with the 7-inch screen. Okay, so let's do a first time turn on. Let's take a look at how long it takes to boot. I like the colors. Fair bit of fan noise. Hantek, your testing solution provider. Look at that. That was no time at all. You know, under 10 seconds to boot. I like the screen. Looks very, very nice. It's actually like this from where I'm sitting. You know, I'm about like 20-30 centimeters above. My eye level is much higher than the oscilloscope, so it's quite a bad viewing angle looking downwards like this. However, it has these legs at the bottom here that you can flip up, and it gives you a much better viewing angle, and that's literally perfect. So the screen is super bright. I like that. It's very nice. Okay, so there is a fair bit of fan noise. You could probably hear it. It's nothing that, you know, it wouldn't become annoying or anything, but right now the house is quiet, and as I was just working away and I had it on, I could hear it quite loud. So you can hear it basically, but you know, I'm sure it's not going to be a problem. My only concern would be if whilst I'm recording videos, then would it become an issue, but I don't think it would. Like, for example, now I'm speaking over the fan noise and you can still hear me clearly, so I would assume that the fan noise is okay. Alright, so let's have some fun now. I think pretty much everybody who tests out on an oscilloscope, the first thing they do is they get a function generator, hook it up and test it out. That's the standard thing to do, right? I'm gonna do something a little bit more quirky involving this. So what's interesting is that obviously you've got this USB port and it will actually output enough voltage to power the Arduino. Now I did take a look at the data sheet of the oscilloscope to see how much the USB port outputted, but it wouldn't tell me. There was no information there. So but connecting on the Arduino to the oscilloscope and you can see it powers on fine, no problem. So what I'm going to do is I'm going to upload some basic code onto here where we're going to just basically output a square wave, go high, go low with 10 milliseconds between them, and just make a bog standard square wave on the Arduino, and then we'll hook the oscilloscope up to the Arduino. So let's jump onto the computer and I'll show you the code that I'm going to use for the Arduino. Okay, so here's the code for the Arduino. Basically we've got pin mode 7, we're setting that as an output, so we're setting our digital pin number 7 to be an output. You can pick whichever pin you like really. And then as part of the actual code of the program, I'm writing high to digital pin 7, and then I'm waiting 10 milliseconds, and then I'm writing low to digital pin 7, and then I'm waiting 10 milliseconds. So we should just see a box standard basic square wave on the oscilloscope. So let's upload this and then get straight to it on the oscilloscope. Alright, so we're back. So literally just connect one wire to ground, the other wire to digital pin 7, and then let's plug in our probe. So you may need to calibrate your probes. I'll show you how to do that later on in the video because that's kind of the boring part, and some of you might already know how to do that. But so here we connect our main part to our digital pin 7, and then our ground to ground. So what I really like about this oscilloscope is for someone like myself who doesn't really know what I'm doing with this, you just come and press this auto set button up here, press that, and then it will literally just take you to pretty much the perfect screen every time. And there you can see we've got our square wave, which is being outputted by our Arduino, which is being powered by the oscilloscope. That's just brilliant, right? I thought that was really cool. That's just, yeah, brilliant stuff. Okay, so next up we're gonna go with this little function generator I've got. This is actually a very cheap function generator. It's a good one as well. It only cost £20 on eBay, and I'm pretty sure you can build these yourself, pretty much the same one. So I'm going to try and do that on this channel, so if you want to see that, subscribe. But I've just got it connected to an oscilloscope probe here, and then I'm just going to connect these two together like so, and then connect the grounds together like so. There you go. So probes connected together. All right, so currently the function generator is off, so when I turn it on we're going to see a sine wave pop up. So I haven't run it yet. So it's currently on 500 kilohertz. So let's turn that down a bit. Let's make that there you go. So we've got one kilohertz sine wave, and then we hit run. And so now this is what I love about this oscilloscope. Just come up here, press auto set. Yeah, it's like you can hear some clicking inside, and then boom. You've got your, this is a bit of a dodgy looking sine wave. So the reason for this is I just need to turn this knob, and then has more to do with my function generator here. There you go. So what I really like about this oscilloscope now is, you know, if I then, you know, just mess it up and really just, you know, turn everything, and this happens to me a fair bit where I just get like lost. For example, if I got something like that, you know, it just looks ridiculous, just hit this auto set. There you go. So we've got our 1 kilohertz sine wave, RMS voltage 1.8 volts, peak to peak 5.4 volts. What's nice is you can press this measure button and it shows it all here. It's just like perfect. This is everything that I want from an oscilloscope, you know. And I get that, you know, if you're a pro at electronics, then this is obviously rubbish to you, and that's cool. But for me, this is amazing. You know, for £170, the fact that I can just, I don't need to worry about anything, hit auto set, you know, and I can hit measure, and I've got everything I need there. And to be honest with you, it gets a lot better, you know, in terms of math functions that you can do, adding and subtracting different waves. It's really cool stuff. For me, you know, for the price that I paid for this, I'm very, very happy with it. I think it's amazing. The menu system is one of the best I've seen as well. So here I can press channel 1 menu, bring that up here, and then you've got these buttons here that control what I'm doing. So for example, right now I've got my probe set on times 10, right? So if I change it to like times 1 there, then I can come over to here, press on the menu and change it to times 1. Then I can close the menu, and then now I've got it on my times 1 setting. Change it back to times 10, you know, channel 1 menu again, and then here times 10. It's just so good. For me as a complete noob, you know, I don't know anything about oscilloscopes. Like I said, this is the first time I've used an oscilloscope, and within, you know, 5 minutes, immediately I know exactly what I'm doing. It's so clearly laid out, clearly says vertical, clearly says horizontal. Yeah, it's perfect. So move the waveform side to side. I do notice that if I move it quickly, there's a bit of a lag, but I assume that that's quite normal, you know. So if I move it quickly, fine, there's a lag. What I like as well, you can actually press this button. So for example, if I move to the right, you know, minus 455 microseconds. If I hit that button, brings it back to 0, which is brilliant. And so you see, because I'm pressing auto set, it brings up this menu, right? And so for this menu, I've got multi-cycles, so showing different cycles. If I just want to see one cycle, I can just hit this button here, and then it will just show me one cycle. It's just so good. Like, for my use case, I couldn't think of a better oscilloscope, to be honest with you. All right, let's play around a little bit more. So if we come here and go stop, and then we go mode, square wave, run it again. We've got a square wave there. Hit auto set. So we've got a dodgy looking square wave there. All right, and then stop it again, and then let's go triangle wave, run again. There we go, we've got a triangle wave. I'm super happy with this. Let's show our sawtooth wave. There we go. Reverse sawtooth. ECG. Can detect my heartbeat. Alright, so let's crank up our sine wave to here. So we'll go to 500 kilohertz, which I think is the max that this function generator can do. Run. Alright, and then again, auto set. Just bring it down. And you can see 500 kilohertz. I don't know what's causing all of those noise spikes there, you can see. Who knows? Maybe I've got some cross coupling going on with these wires, I don't know. Okay, so I've connected the Arduino now to the second channel of the oscilloscope, and have a look. You can see there we've got the Arduino square wave, and then we've got our 500 kilohertz sine wave coming from our function generator. And you can see we've got both of the screens, or both of the waveforms on the screen there. And it's nice. It looks really, really nice. And the fact that you can kind of control each one of them simultaneously, you know, channel 1 menu, channel 2 menu, it's amazing. Turn off the menus, and obviously change each waveform by itself, which is nice. Can move along. Alright, now if you know nothing about oscilloscopes, you're going to be amazed here, just like I was. This is fantastic, right? So you've got this math menu, you press it, and look at that, it brings up a little menu here to say channel 1 plus channel 2, channel 1 minus channel 2, channel 2 minus channel 1, channel 1 times channel 2, and then channel 1 divided by channel 2, and even more. So if you look here, you got the purple math one, which is, you know, highlighted by this, and so you can see this is what happens when you add this square wave with this sine wave. Amazing, right? Just I'm blown away by this stuff. This is just fantastic, and it's so easy to control. So here now you just press, for example, let's go down here to minus, so you subtract the two, and you can come down here to, you know, channel 2 minus channel 1. What happens if you multiply them together? What happens if you divide them together? Or channel 1 divided by channel 2, and then now this one's channel 2 divided by channel 1. And then FFT has something to do with frequency. I don't know too much about it, but yeah, it's amazing, just absolutely amazing. And then to turn it off, you know, just press that again and get it off, and you can turn it off like that. This is a brilliant machine, and we're still not even done. There's still actually so much more that you can do with this thing, and this is considered, you know, entry level basic oscilloscope. For me, this is amazing. All right, so now let's get on to the kind of the juicy side of things, which I'm super excited about. As someone, you know, currently in university, I have to write up reports. I'm gonna be doing my final year project next year, and undoubtedly I'm gonna want pictures of scopes, right, of my different readings and whatnot. And so the best thing that I find about this is the ability to stick a USB stick in here. So obviously I was using this to power the Arduino, but if I just take a USB stick, so here I've just got a 68 gig USB and plug it into here, it will then come up with saying that it's been detected, USB device has been detected, and then you just come over here, press save to USB, it will tell you that it's been saved, successful to save wave. Okay, so now what that's done is that's taken a screen grab of this screen and saved onto here, and the quality is nice. Now if I then, you know, for example, zoom out, maybe make the wave a bit like that, save to USB again, that will do the same thing, screen grab from there. Now it's not just the screen grab that you can take, you can actually get all of the data exported as a .csv file, which is one of those Excel spreadsheet files. So if you come up to here, save/recall, hit save. Now come to here, setup F2, and then so you got local memory, so you can obviously store it in local memory. I'm going to store it on my USB flash drive here, and then now hit save down here. So now I can back out. If I come here, CSV, press that one, save, wave data 41.csv. And so now that saved my data. Come and press back. So once you've set it up from here, you only need to do this once on here, but here you can just go CSV, save, and then it will save your data. All right, so let's jump onto my computer and see what this looks like. So once you plug the USB in, you get this. The one thing that I do need to note though is that when you are trying to save onto USB, don't make the mistake I made. You need to have your USB drive saved as FAT32, which is actually quite difficult to do in Windows 10, especially if you're using a USB drive above 32 gig. If it's below 32 gig, no problem. You can format it as FAT32. I found that the other formatting types, the file system types, they just wouldn't work. So I had to get it to FAT32. What I personally used was Rufus, which is this application here. And then I went to my USB drive, came here, select non-bootable, FAT32, and then that was it. I just formatted it like that. So it worked for me. But all the USB drives, the only ones that worked was FAT32. So just keep that in mind, yeah? So when you're taking pictures of your different waveforms, they'll be put into folders here. So if we open up the folder, we can then open up the image file, and there you can see we've got our screen grab here. It looks good, doesn't it? My date is actually off on my device by 1 day. Currently 25th of February, it's got down here 26, so I need to change that. And similarly here we'll have the other screen grab. There you go. And literally, so you can set any different settings. You could bring up triggers, whatever you want, and then hit that save feature and then that save button, and then it will save whatever's on the screen to your USB. All right. And the final thing is you've got setup 40.set. That's the setup file, which I saved. But here you've got the .csv file, wave data 41. And then here we've got all of the wave data in a CSV file. I don't even know how many columns of data we've got here. So we're on row 3000, still scrolling. There we go. So about 4066, you don't include top row, 4066 rows of data there from that, on that CSV file, from that waveform, which is cool, right? You may be asking, you know, what's someone going to do with all that data? You know, people have needs for it. I personally don't have any need for it, but you could obviously plot that data, for example, into a graph. So for example, if I come up here, if I delete these first few rows, select these two columns, come to recommended charts, and there you can see, look, you've got a scatter chart, and as you can see, it's a sine wave. It's cool, right? Technology, just amazing. Like I said, for £170, this scope is just fantastic. And we're not even done yet as well. There's more. Okay, so this is where all the fun really happens now. So I've connected the USB that came with it at the back, right? In the back of the oscilloscope. And have a look here. We've literally got it. So now if I adjust this down, look at that. So now I've got the oscilloscope data, all of it on my computer. Just, you know, you're talking about £170 here, and it is fantastic. There's a delay of like half a second or something like that, and it's just amazing, you know. Look at that. This for me is exactly what I wanted. I considered buying those Hantek, the small like automotive oscilloscopes. They're like 60, 70, 80 pounds. But this is perfect. I can do both. I can do everything, you know. I could work off my workbench if I want, and I can also work off the PC. So getting this working on the computer is quite finicky. I must say the hardest part is installing the driver, which is difficult, to be honest with you. I'll just try and help you out with how I managed to get it working, but yeah, again, like I said, it is difficult. You've got to go onto the website and download their drivers and their software, right? Then go into your device manager, search under other devices. If you can't find it, right click, scan for hardware changes, and then when you find it, it will be whichever one. So for example, unplug everything, scan for hardware changes, then whatever pops up, then click that thing, right click it, update drivers, then eventually it'll come up here as under DSO measurement device. That's how you know it's working. Then you go into the software over here, and then tools, connect to oscilloscope, and that's it. It's done. But look at this. This is fantastic. I am well excited for this. This is an absolute game changer for me. Alright, so let me show you how to get the software and the manual up, because both of these are very important. So hantek.com, then you click download. It brings you to this page. You want to select basically your model. So the oscilloscope that we've got is a DSO5102P, right? So we're going to just find the DSO5 series or DSO500 series. The DSO500 or 5000P series. Select that, search, and now here we've got the manual. So we can download this. And now we've got a 71-page manual, and this thing is extensive. Like, I've had a quick read through some of it, and honestly, it's absolutely fantastic. So this is the manual both for the 70 megahertz bandwidth one, the 100 megahertz bandwidth one, which is one that we've got, and then 200 one as well. So it's a very good manual. Highly recommend going through it. Me myself, I'm going to skim through it. I mean, I've already skimmed through it, but I'm going to read through it properly as well. Very good manual. And one thing I appreciate about it is that the English is good as well. In dual window mode, push this knob to select major or minor window. When the major window is selected, this knob provides the same functions as it provides in single window mode or single mode window. Vertical controls can be used to display and remove waveforms, adjust vertical scale and position, set input parameters, and perform math calculations. Each channel has a separate vertical menu to set. See below for menu description. So it's very good English. It's not like that backwards kind of like stuff that you normally get from Chinese products. Okay, so that's the manual. You want to come over here to drivers. So again, still having a DSO 5000P series selected. Drivers, you want to download this driver, and then it'll come up as a zip file. So we'll download the driver, open it up. Right, so it comes up like this. You want to come into here, and then you've got this security catalog. You want to basically install this certificate. So you double click it. It comes up here, view signature, view certificate, and then install certificate, current user, fine. There you go. Now you plug in your oscilloscope, then go to your device manager. And so I don't have my oscilloscope connected to this computer, but you want to basically go under other devices. So I don't have that option here, but like I showed you on the laptop, follow that and then go to update drivers and install that driver. All right, so once you've got the driver fully installed, then you want to come over here to application software. Then again, download. So it's got another zip file, 10 meg. All right, so open it up, and then you want to go setup, and then you just run the setup installation, and that's it. Now if we go to our Windows, over here digital scope, and then once you've connected your oscilloscope and you've installed the driver, then here now tools, connect to oscilloscope, and you're done. That's it, and you'll be able to access. So you've now got the software and the manual and everything else. Okay, so let's update the firmware of our oscilloscope now. So on the same page, latest firmware, and you need to pick the specific one that you've got. So I've got the 510. Download. Okay, and then once you're done downloading that, you'll get a .raw file. And with that .raw file, you just have to then unzip that file basically onto the USB. So in this instance, I couldn't open the .raw file, so I had to use this application to use it in order to open the file. So I used the application, got it from Microsoft Store. So I put it onto the USB here, and then I need to come in here, take this .up file and cut it out from there and put it just first thing on the main, like in the top level folder of the USB file, so I can delete the actual folder now. So now eject the USB and then stick it in the oscilloscope, and I'll show you how to update it from there. Alright, so from here, stick our USB stick into the oscilloscope, and then now we come up here and press utility. I'm on page 2. You need to go to page 1. There you go. So page 1 and then F2 for firmware update. And then it's going to tell me, am I sure? I need to press F5 to confirm, and then it will run the update. Alright, and then it will just reboot, and hopefully it should be all sorted. Alright, so it hung on the blue screen there for a while, which is a little bit scary. But yeah, that's working now. And there we go, the firmware has been updated. Nice and simple. Okay, so I just want to briefly touch on the probes. Firstly, I really like these probes. But you are going to need to calibrate them when you get them, and so you might find that you might be getting like quite a lot of noise or whatever. Your waveform might look off. If you haven't calibrated it, the simple way to do it is basically you need to connect to these two pins here. So the bottom one's grounded, the top one's where your main probe goes. So you connect that into there like that, connect your ground onto there, and then you're going to get on the screen a square wave. So if you press auto set, and so you can see that you got a dodgy square wave. So you use this calibration tool, which is basically, I mean, I know they've given you a specific tool, but it's basically just a screwdriver, right? So you stick that into this hole at the top of the oscilloscope, or into the oscilloscope probe, and then turn it there until you get your perfect square wave. So if you just keep turning it around, you'll see it kind of goes up and down, up and down. So you just need to calibrate it to a point where you get your perfect square wave, like that. And there you go. That's it. That's how you calibrate your oscilloscope probes. So let's round this video off by looking at some reviews on Banggood, because these reviews are really what made me get the probe. And I think if you're still watching this video and you don't have the oscilloscope yet, hopefully these reviews will convince you, if this hasn't already convinced you, because for me, I absolutely love this machine. It is bloody brilliant. You know, from the USB saving the images or the .csv files to, you know, connecting it directly to a computer and running it on software, just amazing stuff. So yeah, for me, £170, very, very, very well spent. So let's jump on the reviews. Alright, so firstly, it's rated 4.96 out of 5 stars, and it's 383 reviews. Not one of those reviews were 1 star. Think about that. That's crazy, you know. Not one review 1 star. So I've selected all the reviews that are in the United Kingdom, because when you select non-United Kingdom, then they come up with like in a bunch of different languages. So all these ones will just be English languages. So the first review, which is the top one here, August 2020. And I always look, when I'm looking at reviews, I look at the date, because it's important. I might be getting a newer revision. So, you know, if you see 2017, 2016, 2015, then I tend to ignore those reviews. But you can see here 2020, 2021, 2021, 2020, 2019, 2020. So yeah, let's take a look at them. So this is fantastic oscilloscope. I didn't have enough time to use it, but I just couldn't wait to write a review. The amount of features in this thing is insane, definitely worth the price. And if you're a hobbyist or even working on some professional electronics, this is a must-have in the lab. An essential instrument for sure. The delivery was blazing fast, just 3 days, which is the same with me as well. It took 3 days. This scope is also hugely popular in the electronics community, and the manual is extremely thorough, which I mentioned is 71 pages in the manual. So if you ever run into trouble or you want to tinker around with the scope, I can assure you always find something online, which is true. And it's got a bunch of pictures here. So this is my first proper oscilloscope. Same with me. It is an excellent starter scope. Construction materials are excellent. Shipping was fast. Product does exactly what it says in the tin. Took ages to finally buy this. I've always wanted a scope, but can never justify the expense, which is the exact same thing with me as well. He's got a picture of his little circuit. Fantastic unit, does everything and more than I expected. If you do electronics, don't think twice. This is the business. Nice oscilloscope, thank you. This is a nice review which I wanted to highlight, which he talks about the mains power. If you remember at the beginning of the video, I said don't use the plug that came with it. This guy explains why. So this product required a mains power lead that supplies feed L, return N, and earth E, and must be grounded. As supplied to myself from China to the UK, it came with an EU style terminated power lead and a non-compliant UK adapter. This combination removed the earth protection, which is true. I suggest if this happens to you, to your order, you either replace the power lead with a UK compliant lead, which is what I've done, or replace the EU plug with a UK plug if you are competent enough. Yeah, I mean, no point to do that. I would suggest that you ask Banggood to include the UK specific power cable with the correct fuse. And then he just goes on to praise it. So yeah. Okay, only had this item for a couple of hours and carried out a basic functionality test. So far so good. Scope is so easy to use. Plug it in, turn it on, and away you go. The display is bright and easy to use. So you can see literally just, review after review after review. Everybody's happy with it. And me, myself, I'm completely happy with it as well. So would I recommend it? The obvious answer is yes. And I'm going to have some fun with this scope. And more than likely, you're going to see it in a lot of my videos moving forward. So if you enjoyed this video, leave a like. And hopefully I shall see you guys around. I'm doing electrical engineering. I'm in my second year. Subscribe. Go on.